All right. Hello again, Professor Henry. We're back again. Project Milestone 2. I don't know if you watched my first video yet, but I did this once and that's why everything's filled out already. So this time we have our AI controllers. Um, I made a it called for 4 controllers, so I made a specific one for all of them, but Blinky just uses the regular AI controller because Blinky just comes straight at you no matter what. So there was no need to like make a separate controller if I was just going to have it do the same thing as the regular AI controller, and I didn't want to have all of the other AI controllers be inheriting from something called AI controller Blinky. So I just left it as the AI controller. Um, the rest will attempt to come at you from a specific side, um, which I will detail in. Let me get there really quick. In my AI personality.txt, I'll detail that in there. Here's the same description as before. I'll say what sides they go to and they try to attack you from. Um, So their chase functions all send them to a different side of the player, or they try to get to a different side. Though the way our obstacle avoidance is, sometimes it creates really weird stuff. Um, anyway, so to start it off, I guess I'll just go down the list some more. Um, tank still moves and shoots, and includes 4 AI controllers and tanks. You can see my 4 tanks from here. I have Blinky, Clyde, Greeny, and Inky. They're all sitting in a separate corner. Here's my 4 controllers right here. Um, and here is my tank still moving. There's everybody still moving, actually. So, so, so I have a different FSM per tank. I think I have them all open here. We'll start out. This is Blinky's. Everybody else kind of goes off of Blinky's. And that's where they all get all their stuff from. Everybody else's is just an update function. So we've got our components here, our target component, our own transform, a list of waypoints, and then we have a bunch of variables like what avoidance stage we're at. The avoidance time is how long they go for before they turn again. The exit time is when they exit the turning avoidance stage to see if they can move forward again. Um, and then we have something, an enter and exit time for the state, which is really just used for the check for flee. I have a float AI sense radius. This is practically their hearing. Once you get in here, they hear you and they begin to come after you. Um, Still have to implement can't see. So then I have a resting health rate that heals. That's when they're in their rest state. The flee distance, obviously, that's how far they flee a current waypoint, close enough for if they're close enough to the waypoint to go to the next one. And then I have a stopping distance, so they all stopped hitting our player. Which now that I said that, I think I have to actually still go and set it on all of them. I probably only set it on Inky. So here's my enum for the states. We have chase. They're in alphabetical order. So we have chase, chase and fire, check for flee, flee, patrol, and rest. Everybody starts on patrol. Then I have a variable to hold our state, and here it says chase. So I'm just gonna say it equals patrol. That's why when I was putting them on there, they were coming out as chase. So then we get everything we need here in our awake function. And before I dive into this, we're just going to skip down right to the behaviors. So here's my avoidance. It's implemented in every single thing, every single state actually in the FSM, it's implemented so that you're always checking for obstacles to dodge. If we're in avoidance stage 1, which is just an integer, nothing special, we rotate to our left. And then if our can move doesn't detect a collider that's not the player, we can move, and we move forward onto avoidance stage 2. Otherwise we just keep rotating. So if we can move forward, we do, and we move forward for a certain amount of time by our motor move speed. And if we don't hit another wall in that area, that time, we exit, and we're no longer avoiding. So that's kind of how it works. It turns and then moves forward, and if it can move forward for the amount of the exit time, then we consider ourselves able to move. There's nothing in front of us, and we exit avoidance stage and usually just keep moving forward. All right. Now I should improve this by adding a distance, but this is the can move from the canvas shell. Um, it is from the canvas shell. It's just a simple raycast forward. I just took it and called the raycast hit inline, so it wasn't just a raycast hit sitting out here. That looked weird to me. And I can understand that I'm creating it, and I'm creating it right here. This is where we create this hit variable right here. I'm okay with that. So then if it hits something that's not the player, it returns false and we can't move. Otherwise, it returns true. But something is weird with that, because I'm finding that at times my AI does try to avoid my player, but it started happening when I added the new script. So I think it's actually caused because they can't reach their side, or maybe they're just somehow raycasting through my player and seeing a wall. I am driving around trying to avoid bullets and stuff. So okay, all this can see was from my Sneaky McSneakface project. It's actually the exact same one, so I'm not going to go over that. You've heard me explain it before. Same with the change state, except we just track our state enter time, and that's purely for one state. Here's my chase state. We rotate towards our target plus the offset, which when we were talking, this is kind of what I got out of it. And I feel like this actually makes them rotate a little bit to the right or the left. But it did look like Inky and all the other ones were trying to get to my right side, but they never stopped moving and they never stopped rotating, so it's not like they actually uh get there and stay there. They only stop moving once they get within the stop distance. So I guess they do, but when they're rotating trying to get to like that point 5 units from this is Blinky, so it doesn't say anything, but for instance Inky's 5 movements to the right, it's sometimes hard for them with the tank movement because they can't just turn and go to that space, so they end up rotating around the player a little bit. Uh, but anyway, um, if we're if the distance is greater than our stopping distance to target is greater than our stopping distance, we move forward. I tried to make this a square magnitude to not do vector 3 dot distance. I might have to talk to you about how to actually transform that, because it was like, nah, you can't use this as a float. It was returning a vector 3. So, yeah. This is my check for flee. It does nothing. Um, but it does create like a kind of minute where the AI looks like it's deciding to flee, and then what it does is, well, I'll get to that, but that's nothing. So then here's my flee. We already did it in the canvas shell. So forgive my silence. Oh, okay. I just thought I could make it better there. So here we get basically the vector to our target where we need to go, and then we flip it so it's actually away from our target. We normalize it so it's 1, it has a magnitude of 1, and we can make it whatever we want. And we multiply it by flee distance, and flee distance is actually a designer set variable, so they can choose how far they flee. Then we just add the flee to vector to our own position, and we go. We rotate towards it, and we go. And that's it for flee. Super simple. Here's my patrol state. This is exactly the loop state from the canvas shell that you had to make. So, if we're facing where we have to rotate to, we do nothing. And then once we're facing it, well, okay, so basically we rotate towards it, towards our waypoint position. And then once we reach there, we stop and just start moving towards it. So the tanks will actually stop, rotate, and then go. And then here's a use of square magnitude. Maybe I could look at that, because this is a float and it's comparing it to it. So maybe I just needed to do this. No, see, that's what I tried like 4 different ways to get it going. I'll just talk to you about it tomorrow or whatever. Anyway, we move towards it, and then if the distance between our waypoint is less than our close enough variable, we increment. Well, and if our current waypoint count is less, if our current waypoint is less than the count minus 1, we increment it. And then if else, if it's, if it's not less, if it's equal to or somehow greater, we set it to 0. So we just go back to the first waypoint. And then here's the rest. I just kept it from the canvas shell. We just take our pawn health and we set it plus equals. So we basically just say it. We just add this to it. Bye, Jim. And basically we just take our resting health rate times time dot delta time, and since the resting health rate is 1, you pretty much just get health for how much time has passed. But we are adding that in the same step where we're adding it and setting it equal to our health. And then this is here so we don't go over our max health. We just set it equal to math.min, which returns the minimum of 2 values. And when we say our health and our pawn max health. And what this does is our pawn health should never be more than our max health. So if it somehow does become more than that, it will set it to this, to the max health, which is, I think, it varies per AI, but yeah. So there was the chase, flee, and patrol behavior. I do have a field of vision and stuff, and the designer can set it, but I'm currently not actually using can see anywhere in my code. I'll have to I'll have to schedule something with the tutor or meet up with you or something to understand this better because I thought I got it, but when I started wrapping it around stuff in my code, it wasn't working. And I think the way my code is written, they were just chasing me anyway. So maybe I need to wrap that in an if statement with can see. Um, I'll mess with it on my own time too. Um, but let me show you. You've seen it. It's just that AI sense radius. This is basically just our like here circle, and it's just a number. And I use it everywhere to chase the player. It says it in my comments too. I have everything commented out. But that's basically what I have for hearing. I have the function for seeing in there. So I guess I could actually leave this sense radius for hearing. And well, I guess it's not a distance plus noise maker, so there's that. You're not really making noise. Anyway, I'll leave that at that. And click on something really quick to show you. Here's the field of view and line of sight, the field of view and a view radius, which these might be flopped, but they're not plugged in, so there's that. They're there, but they're not in use. Then I'm gonna show that the AI and the player tanks use the same components. Let me, except for the AI controller, let me collapse that so it's easy to see. All the AIs use this. They all have their own AI special controller, but they all use a pawn and a tank motor, um, and then the same sphere colliders and character controllers. Huh. Somehow a box collider didn't get added to everybody. Okay. So they all use the same sphere and box collider and everything. Even the player. The player has a different controller, but we use our pawn. Our pawn script, which oh, that's why I'm not using the player pawn because there's nothing in there yet. Okay. So they all use the same pawn script and the same tank motor. They just have different controllers. Right now the controllers are on them. Um, Now that I have a list of enemies and once I have a list of players, I'll put the controllers on a separate object so that they can grab from that list. And then maybe if we're gonna stick with this like Pac-Man ghost tank thing, I can just tag each tank by like Inky, Greeny, and Blinky, and just have the AI controllers find them that way. Or something. There's plenty of ways. The players will be a little bit different. Anyway, so there was the components. I don't know if showing you on there is enough. I don't think I need to go into code to show you that they're all the same components. But my tank motor, my pawn, my tank motor and my pawn are in here. The AI controllers are in their own folder, and then the player's input controller is just sitting right there. So we'll get to the unique FSM part right here. So they all start. Here's the whole FSM. It's on the GitHub. But here's the whole FSM. Now the uniquest part, the rest of they all have stats that are changed and modified, so all of their like tank motor and pawn, like they have like different fire rates and stuff. But the stuff that's different about their FSM is their target when they chase you. Blinky will just come at you, no matter where, from all sides, no matter what. That's why it's a vector 3.0 on all of the chase functions. I guess that was the second one. Yeah, see, vector 3.0 on all the chase functions, which are just there and there. Inky, well, and just to show you, here's my avoidance call in all parts of the stage. This is taken directly from the first AI controller, so it's there. And then in every stage, they also check to see if they have low health, so they need to flee. In every stage, in every state, they check to see if they have low health. But then Inky over here will go to your right. Target.transform direction.right. I tried to use that local space thing you showed me. But it looks like it says this transforms direction from local space to world space. Not from world space to local space. Oh, no, that's right. No, I want to yeah, no, that's right. Sorry, that's right. Yeah, because I want to take my local space of my target and translate it into a world space. So, so there's that. um, they'll Inky will go to the player's right on, or is supposed to go to the right on both of them. And that's pretty much what's different about Inky. The rest of the patrol state and everything is the same. And then we got Clyde over here, which you can see I just finished doing Clyde. Um, Clyde uses a vector 3 dot forward, so Clyde will actually try to go in front of you. Um, but like the other Clyde, as long as you don't get close to him, he's not dangerous because his sense radius is so low he will not chase the player unless you actually like get in his path. And then Greeny, I wanted them to come up behind, so I'm trying this negative vector 3 dot forward because I think that would make it behind. So you can see here in the chase and fire one, I set the offset to negative 3 dot forward, and we go with that. Now, I did explain this super far on my other video, but I'm recording this probably before you got a chance to watch it. So I will go over the finite state machine again, or machines this time. I'm only going to go through one since I showed you the difference in the chase states. And then the rest is the same. So if we're not in avoidance stage 1, we do avoidance maneuvers. Else we're going to chase the player, and this is the chase state. If our health is below half our max health, we change state to check to see if we need to flee. And then else if our target is within our sense radius, we chase and fire. And that's why I'm guessing actually Blinky and Inky will both start shooting at the player from kind of far away. I was wondering that earlier, now I know. So then we have the same thing again with the avoidance stage, but the else this time is just our shoot is the same as the last one, except we also put in the shoot here. Then once again we check to see if we're below our max, our below half our max health. And then if And then if our target, if it's greater, if the distance between us and the AI and the target is greater than the sense radius, we'll go back to chasing them. Now, Blinky and Inky have super huge sense radiuses, and they can pretty much see you from across the map or hear you from across the map. Because I always wanted Blinky to be chasing you, and I wanted Inky to be kind of dangerous, but I did not have the knowledge to. Well, maybe it's not the knowledge. With a little bit more time, I could probably make Inky's actions go off of Blinky's, but for the sake of brevity, and I don't know if the rest of this project is going to stick with Pac-Man ghost tanks or not, or if I'm just going to revert back to my regular enemy pawns. But anyway, they go back to chase. This is the flee state. Once again, we're checking if we need to avoid stuff. Um, Otherwise, we're just fleeing. Um, then if the time is greater than or equal to our state enter time plus our state exit time, um, we check for flee. And in the flee state, or in the check for flee state, which is down here, um, that actually you'll see why we go back to check for flee from flee in a little bit. Um, so once again, we're avoiding in our patrol state. Otherwise, if we don't need to avoid, we patrol. Then once again, we're checking to see if our health is below our max health, below half our max health, and then we'll go to check for flee if we have to. And if our target's position, if the distance to our target is less than or equal to our sense radius, we go into a chase state. So here's the check for flee. Basically, we once again see if we need to avoid stuff. Otherwise, we're checking for flee, which is really just nothing. The actual checking, the actual like checking if we need to flee is done right here. So if the target is the distance between our target and us is less than or equal to hmm. So basically, never mind. If the distance between us and our target is less than our sense radius, so they're within our senses, we still need to flee so we don't die. Otherwise, we can rest where they regenerate health. And this is the rest state. We just do the rest function. Um, we're not moving in this state, so I didn't do avoidance because they stop in the rest state. There is no moving. So I was like, I know it calls to have avoidance at all times, but I don't think you need with the way our AI is set up right now. They're not detecting if they need to avoid bullets. So I just didn't do any avoidance things in there. If they were still having to worry about like dodging projectiles, I would put it in there, but we don't have that, and I don't know if we're gonna do it. So, then we have this that I described. They're close enough to us within our senses. We continue fleeing. Otherwise, if our health is greater than or equal to our max health, um, so this was what happens if our health is greater than or equal to our max health. We check to see if they're within our sense radius again while we are resting, and we chase them if they are now that we're at full health again. Otherwise, if they're not, we go back to patrolling. So that's the whole state machine explained, taken apart, because I did it in the other video. I don't know if this calls for it to be completely picked apart, but in this one I did explain that all movement behaviors have chase and flee and patrol and stuff I showed you, but the rest, I know it says all of those are expanded, but the rest isn't moving. I can throw it in there just to please. Um, the requirements, but every other state that actually moves has it. And if you're not moving, I don't think you need to check to see if you need to avoid obstacles. If we add in something where you avoid bullets, though, I will put that in there. So now our game manager exists. I really only use it in the finite state machines and the AI for our game manager.instance.player to get the player object. Let me. But that's the only place I use it. The shells use a different method where they don't even have to interact with the game manager to damage people and stuff. We have point tracking on ourself, so I haven't sent any points back to the game manager because I'm not displaying it on the screen yet. If we end up adding UIs and stuff, I'll have the points sent to the game manager. But for now, here's my game manager. We have a list of our enemies. We have our player. I have this commented out, this public score.text, because I'm keeping it in here just in case we do add it. I'll delete it in a little bit if I figure out we're not going to. But that will update. The method is in there commented out. Well, actually, I think the method's in there, just unused. No, the method for scoring is still in there, but that's just commented out. So then obviously here's our singleton, the game manager static, the public static game manager instance. We don't destroy it on loads. We get our player right in the beginning. And then I just have this in the update because if our player gets destroyed, we'll want to have it. And then here is some more commented out stuff for score. It's from my platformer when I was switching all those scenes to find the score text again when it gets destroyed when you get a game over. Otherwise, you get all these errors and stuff. So there's that. So our game manager is pretty light at this point, but we're in the testing phase, getting everything together. I don't actually have like a level or anything for this to handle all that stuff with, but I'm sure as we go on, I'm going to fill this game manager up. So that is about everything. It is error free as I play. You'll see if I can shoot people and get them low on health, they'll flee before Blinky kills me. Man, I'm really not good at my own game. Not one hit? Interesting. Very, very interesting. So if Blinky wasn't stuck here, they would be fleeing. As you can see, flee. Oh, and Inky killed me. But they're stuck in some sort of loop here. So hope you don't mind a little bit of troubleshooting in this video. But why is Blinky taking damage? Oh, that's why. Okay, so apparently nobody else can take damage except for Blinky, and that's because I forgot to tag them all as enemies. So we're going to take this, apply all. We're going to take this, apply all. We're going to take this and apply all. And we might as well apply all here too. It's been doing that. Not really sure what's going down, but see, so when the player does die, I'm not checking for player death yet because I don't know when we're gonna handle that in class. If we're not, I'll just add some stuff myself. Now that we're just doing, well, not just doing pickups. Pickups can be a challenge too, but I find them fun. So, um, I really only get errors if the player dies. I don't have any checks in place because we haven't dealt with the game over yet. So I don't even have lives or anything like that. But I do have like score and points and stuff. So let me see if I can get an AI to flee without just putting it in the flee state to show you that it works. Let's get ooh. Okay. Oh. You don't have good thing you don't have to watch this. You'll probably just skip through it, but Blinky, man, I made a scary tank. You gotta serpentine patterns. Serpentine. Oh no, I killed Inky before they had a chance to flee. Okay, this is gonna be fine. We're fine. Oh man, that tank is just so aggressive. Oh no. Oh no. Okay, so I'm griefing Blinky so I can show you this flee state. Look, there Greeny goes. Greeny is in the flee state. Now, Greeny's flee state actually doesn't last as long as everybody else's. So, she'll be back in a little bit. She's resting now and going into her rest state and regaining her health. And now Inky is on me. But keep an eye on the AI state in the inspector. If I don't go... Oh, I caused them to flee again because I got too close. If I don't go near... Oh, I died. Okay, well now it'll switch back by itself. Fun times. Sorry, I got a phone call from there. So either this flee state is just lasting really long, or they can't. Well, maybe if I don't exist, they can't sense me, so they would leave too. But so we're gonna try to run that one more time. You saw flee, you saw arrest, you see him patrolling and all this. There. Blinky is gonna flee from us. And I'm just gonna stay away from Blinky. And we're gonna see that she will eventually go into a rest state much longer than Greeny would, and then go back to patrolling. Well, actually, they will go back to chasing me. They will go back to patrolling probably for about a split second, but they can see me all over the map, so they'll probably go back to chasing me. Uh-oh. Clyde is having an issue. Huh. It's like they get stuck right there. Like, watch. Weird. That might be where the waypoint is actually located at. Um, hmm. So there is an issue. There's an issue with this right here. So the longer the game goes on, the longer their flee state will be. Because the state enter time was 66 seconds. So he would have been in flee state for over a minute and a half. So I'll mess with that code. It's unintended behavior. Maybe I'll make a variable for the state exit and just have it set as that instead of comparing it to time.time. Well, no, because time.time grows too as it goes on. So I'll have to see what's going on there. But other than that, let's see you in this video, and I will see you next week.